Okay, welcome to this lesson on inverse proportion, which is the last of the three lessons we're doing on proportion. You'll notice as we go through today that the format is fairly similar to the direct proportion questions we've been doing. The only upgrade is the fact that we're now doing inverse proportion rather than direct proportion. So by the end of today, you should know the difference. You should know what inverse proportion means, and we're going to solve some inverse proportion problems and draw the graphs. So what I'd like you to start with is to pause the video and have a think about this starter question. Now, when you're doing that, do make sure you think really carefully about what is sensible in response to that question. Welcome back. Now, if you've got the answer 48 to part A, then do stop the video again and think really hard. Think about if one builder takes 12 days to build a loft, how long should 4 builders take? Should it take longer for 4 of them? And of course, what I'd hope is that for part A, you've got the answer 3, and that for part B, you've got the answer 2. Because if I have got 4 times as many builders, then I'd hope that the loft conversion would take a quarter of the time. Likewise, if I've got 6 times as many builders, then your loft conversion should take a sixth of the time. And this is typical of these types of questions that we call inverse proportion questions. An inverse proportion is when I double one thing, the other thing halves. Or if I triple one thing, then the other thing gets divided by 3. So if I've got 5 times as many builders, I would expect my loft conversion to take a fifth of the time to build. So the next thing you need to do is just stop the video and copy that statement there. The other words we might use are, instead of inverse proportion, you might see the words varies as the inverse or varies indirectly, all mean the same thing. Okay, welcome back. We're going to do some questions, and as I get it into shot, we're going to do this question together, and hopefully as we read this you'll work out that actually it sounds really, really similar to all those questions that we've just been practicing for direct proportion. So this time it says y is inversely proportional, and so we'll have to work out how to deal with that, to x, and y is 3 when x is 4. There's the information in the question that always allows you to find k. And we're going to do the same as always. We're going to find an equation, we're going to sketch the graph and find out some things afterwards. So let's firstly work out how do we deal with the inversely proportional. Well, if you think back to what I said right at the beginning, if I have 4 times as many builders, then I would expect my loft conversion to take a quarter of the time. So instead of doing something completely different, what we write is y is proportional to 1 over x, and the 1 over deals with the inverse part of this sentence here. So we write y is proportional to 1 over x, and the 1 over is the bit that deals with this inversely here. Now, you know what happens next. We take this symbol here, the proportionality statement, and we replace that with an equals k. And this time I'm just reinserting the multiplication sign because it's not nice maths, just write k 1 over x. Now, you could leave it like that, but actually it might be a little bit better if we tidied it up a little bit. So I'm just going to tidy that up. And to do that, I'm going to write this as k over 1. And then I'm going to do top times top, bottom times bottom to tidy up that fraction so that it looks like this. And that's just a slightly easier equation to work off. So that's where I'm going to start. Now, you know how it works from here on. Everything I'm going to do from here on inwards is very much the same as we've been doing before. So we find out the information in the question. Y is 3, x is 4. Put those in the right places. And we're going to rearrange to find k. Now this time I've got k divided by 4, so I need to get rid of the divide by 4. The opposite of dividing by 4 is to multiply. And 3 times 4 is 12, so I've found out that k is 12. Of course, you know what happens next. We must remember to go back and take the equation and insert my k value in the right place, because once I've done that, the rest of the question relies on me knowing that equation there. So far I've found the equation. Now I need to sketch the graph. And again, we've thought about this type of graph fairly recently in the last set of lessons that we did. And hopefully you picked up in our sketching graphs lessons that a 1 over x curve looks like this. And that was the last of the sketching graphs videos that we've done recently. And this is very similar. This is 12 over x, and essentially the shape is the same. The 12 just makes it a little bit steeper. But given that we haven't got any numbers on those axes anyway, it's difficult to kind of make it much steeper and it be exact about it. So all they're looking for, if they ask you to sketch the graph, is that you've got this characteristic 1 over x shape, and the 12 would just make it steeper. Okay, so we've done A, we've done part 2 as well, and now we're going to do the B and the C. And again, if that's exactly the same as when we did it for direct proportion, it's just the equation's a bit harder this time. So let's find some more paper. Part B says find y when x is 2, and if you remember, this was my equation, so I'm going to start with my equation every single time and find y when x is 2. So I'm just going to put 2 in here. So this says y equals 12 divided by 2. Well, I think 12 divided by 2 is 6, so that's B done. Next up, let's do C, write the equation. This time they've told me y, so I'm going to put the 30 in instead of the y. Now, this is actually a slightly harder equation than we've looked at when we did direct proportion, because the x is on the bottom of the fraction. And whenever the unknown is on the bottom of the fraction, that makes life pretty tricky. So the first thing we always do when the unknown's on the bottom is we get it off the bottom and it turns up on the other side. So this says 12 divided by x. We don't want that divided by x because this makes life really difficult to find x. So I'm going to do the opposite of dividing by x, and I'm going to multiply by x. And that means over here, I've got the 30 and I've multiplied it by x. So I've got 30x. Over here I had 12 divided by x, and then I multiplied by x, so that gets rid of the x and just leaves the 12. So I haven't finished. I don't know what x is yet, but I'm nearly there, because now I can just divide by the 30. And if you need to, reach for a calculator, but hopefully you could maybe do that in your head. And if you can't, reach for your calculator to get x is 2/5 or 0.4, whichever you prefer. It's quite a nice number, so I can leave it as either a fraction or a decimal. So what did we do? Let's just check that we understand the difference between the questions we were doing before. I write the same proportionality statement, but the inversely proportional tells me I do 1 over the x, not just x. Then I replace this with the equals k, and then I just tidied up my equation a little bit to make it easier for the rest of the question. You don't have to do that, but it makes your algebra a little bit easier. And then I put in the numbers and I found k, and I rewrote it like this, just like I've always practiced. And then I answer B and C by using the equation. Let's do one more example together, and then it's going to be your turn to have a practice. So this is example 2. And I've used P and Q again. I've realised I used P and Q in all of these videos. It doesn't have to be those letters, can be any letters you like. So P is inversely proportional to the square root of Q. Now there's quite a lot going on in there. There's the inversely proportional, so I need to deal with the 1 over, but also there's a square root of Q this time, so I need to make sure I deal with that as well. So ready? P is proportional to, now remember it's inversely, so I need to do 1 over, and then it says square root of Q, so I need to make sure I write square root of Q. Then I do the same as before. I replace the proportion symbol with an equals k. And I'm going to just tidy that up again just to make my life easier in the next line. So I write that as k over 1. And remember to multiply 2 fractions. I do top times top, bottom times bottom, tidies up. Looks like that now. Okay, so this is my equation. And somewhere in the question is enough information. P is 5 when Q is 4. P is 5, Q is 4. Don't forget to write the square root symbol, still there. And now square root 4, that's just 2. So instead of writing k over square root 4, I'll just tidy that up and write k over 2. Get k on its own, got to get rid of the divide by 2. Opposite of dividing by 2 is to multiply by 2. Tells me that k is 10. Don't forget, haven't finished. Grab the equation, insert the k value. That's the equation I'm going to work off for the rest of this example. Okay, so I found my equation relating P and Q. Now I need to do B and C, which is, again, as always, write the equation, put in the number they gave me. So they told me that Q was 25. So I'm going to put 25 on the bottom there, underneath that square root. Don't lose your square root at that point. Now I'm going to work out square root 25, which I know is 5. So this really just says 10 divided by 5, and 10 divided by 5 I know is 2. So that's me done on that one. Oh, you can't see. Now for part C, I'm just going to get a bit more space. So the equation that I'm using is P is 10 over square root Q, and for part C they've told me that I need to find Q when P is 15. So I'm going to put 15 in here. And again, I've got that problem that I had last time where the Q, the square root Q in this case, is on the bottom of the fraction. And there's nothing we can do while it's on the bottom of the fraction. So the first thing I'm going to do is get rid of this divide by square root Q. And to do that, I'm just going to do the opposite, which is to multiply by square root 2 Q. Okay, don't try and do anything with that Q whilst it's on the bottom of the fraction. Don't try and deal with the square root, don't try and find Q. Instead, we get it off the bottom of the fraction by doing the opposite of divide by square root Q, and that is to multiply by square root Q. So over here, we've still got the 15, and now it's multiplied by square root Q. It's still quite a mess, but it's easier now it's off the bottom of the fraction. Over here, the divide by square root Q got cancelled out by the multiply by square root 2, so all that's left is the 10. Next up, I'm trying to get to this Q, trying to get this on its own, so I'll get rid of that times by 15. And to do that, obviously, I'll divide by 15. So that just leaves the square root Q over here, and 10 divided by 15, I think that simplifies to 2/3, so it looks like that. And then hopefully you know that if I've got square root Q and I want to find Q, then to get rid of that square root, I'm just going to square both sides. So squaring square root Q gets me back to Q, and I know that when I square 2/3 I get 4/9. You can't see it, but I know that. If you don't know, you can just square that on your calculator. This is a calculator question. Okay, so we've done 2 examples, one straightforward where it was just inversely proportional to x, so I just write 1 over x. The second one more complicated, it was inversely proportional to the square root of q, so I wrote square root of q on the bottom this time. That's the examples for you, so now you're going to go and practice some.